First speaker today is Molly Miller. Molly is a systems engineer at Flying Circus Internet Operations, where she works in the platform team on data center networking. Please welcome Molly and enjoy the talk.
Okay, so as Wolfgang said, I'm from Flying Circus. I'm going to talk a bit about what happens when software people try to use EVPN. So, a bit of quick background on Flying Circus and me. So, at Flying Circus, we do managed hosting for bespoke and complex and business-critical applications. The pithy marketing line is DevOps as a service, and what that means is we take over operational responsibility for customer applications for customers who aren't able to or don't want to do this themselves. Our founders are both software engineers by background with a lot of experience in open source, and this has a very big influence on our methods and processes. I'm a systems engineer. I've been at Flying Circus for 2 years now, and my focus on the platform and infrastructure team is data center networking, and in particular, the EVPN migration we've done. So we run our applications in VMs. We do VMs. And each VM has 2 network interfaces. There's a front-end network for unfiltered access to the public internet. And then there's a services network, which is very heavily filtered and for application back-end traffic and some non-public functions like monitoring. And there's some other networks like out-of-band management or RSF cluster, which aren't shown in this diagram, which also are managed separately. These are all shared layer 2 networks, which are bridged by the hypervisor, so the VMs all see each other. So how does this look physically in the data center? Well, before EVPN, this is how it looked. Each network had its own physically separate infrastructure. So we have separate switches for every logical network here, and every server has a separate port on the back for every network it needs to connect to. This has the advantage that the switch config is very simple, and if one dies, we can just swap it out and replace it. Easy as that. But there were some pain points with this, which were starting to be a source of friction, and, well, we wanted to do something better. In particular, we don't have any active redundancy, so if a switch fails, that means we have a hard outage, and we need to send in the remote hands to swap over the switch and move all the connections over. It's a bit of a hassle. This also has very poor scaling properties. If we want to add new networks, then we need to go and buy a bunch of network cards and a bunch of cables and more switches, and the capital cost is very big. And we don't really have a good story for per-tenant isolation. These are all shared L2s, and whilst we do run a managed firewall on every VM, this is really a workaround, and we don't consider it ideal. So we wanted to build something better to address these limitations, and we wound up going with something based on EVPN. And this looks like this. So this is a rooted layer 3 underlay with redundant connections between the hypervisors and the switches, and the routing is all done with BGP, IPv4 unicast. We then run a VXLAN overlay on top of this, and we terminate the VXLANs directly on the hypervisors. So these are Linux servers which have a bridge interface on them which the VXLAN is plugged into. And every old layer 2 network, which we used to have, is now a VXLAN. So we have the front-end and services networks, which are these shared VXLANs. Some of the Ceph functions are in there. Out-of-band is still separate because it's out-of-band. And we got some nice things out of this. There were some benefits to implementing the network this way. We've reduced the number of cables per server, which is good for the cable salad management. And adding new networks, if we ever have new functions that we want to add to the network, is just a matter of configuration. We just update a configuration file, and it all happens to work. This is also all based on open standards. We have a bit of a checkered reputation when it comes to buying switches from a vendor, which then gets bought out 6 months later. And then in some cases, the prices go absolutely insane, and we can't afford them anymore. And we're a bit tired of that, and we'd like it if this didn't happen anymore. And whilst we don't really have per-tenant isolation, we're still running big shared L2s, but virtualize. But we now have a basis on which we can build this per-tenant isolation that we want to have in the future. But we can build all this nice new network in the greenfield, but the real party trick is in the migration from the old world to the new world. So in terms of timescale, the initial R&D and lab work lasted from September 23 to February 24. And then at that point, we switched modes, pulled in some other colleagues to do all the rest of the integration work to get it ready to deploy to production. And in May 2024, we then did our production rollout in the space of a week. And a lot of the development work and development effort that went into this is making the rollout go smoothly. A lot of the effort was in the preparation here. There's this long tail of little things which we have to take care of when we're doing this whole migration. So we have 1 week. We have not quite 50 servers to migrate. So from that, we can calculate a hard limit on the amount of time we have for each server, especially if you want to do a staged incremental rollout. We established that rebooting every server is actually too slow. There was me and one colleague of mine in the data center, and between the both of us working on this, if we have to wait for the server to reboot, which can take 5 to 10 minutes depending on the hardware, then we've run out of our time box and we don't have any buffer at the end. So we put a lot of effort into ensuring that we can get robust reconfiguration online without rebooting, even for complex network changes. And we have our centralized control plane, our control panel, which has all the configuration, which is then pushed out to all of our machines. And the click path there was suboptimal. It was a lot of clicking around, but this is software we've developed ourselves. So we just implemented a magic button, and you click the magic button, say yes on the next form, and then the network is converted to this EVPN-VXLAN setup. And that made things go a lot more smoothly. As for the actual process in terms of physical data center hardware, we wound up in this halfway house setup for performing the migration. So on one of the VXLAN switches, we terminated the VXLANs directly on the switch, which are otherwise only terminated on the hypervisors, and then broke out the VXLAN there and bridged it to the old layer 2 devices. And then we could incrementally move every host over. So we can drain the traffic off of each host, live migrate the VMs elsewhere. We can then fix all the cabling. We can update the config, plug it all back in, test that it works, and then put the VMs or whatever other workload back on there. And with that, we can then do every host incrementally. And there's a couple of little things in the background here. We had this wonderful spreadsheet with a very detailed checklist for every server, so like 50 columns and some 20 rows each with every single step in detail. And, well, it was mostly smooth sailing. For the most part, it went very well. There is an asterisk here because it wasn't totally zero downtime. There were 1 or 2 false moves and some unexpected issues. There was a cable which got plugged into the wrong port in the switch in the middle of the migration process. And there was one nasty problem with a faulty cable dropping only large packets. Yeah. So there were no major outages, though, and we didn't have our hands forced into any planned customer downtime. And, well, I have here some pictures of the cable salad diff. And on the left, you can't even see where the switches are because there's just so many cables there. I do have to point out that this has grown historically over several years. But now that we have physical redundancy, if we want to clean the cabling up, we can just pull a cable and it doesn't matter. It's great. So that's the story of how we got to where we are. And there's a couple of technical points which I'd like to discuss as well. So first of all, switch port management philosophy. Flying Circus is a netbox-free zone. We don't use netbox. Now, part of this is that we have our own configuration database application. We're a bunch of software people. We wrote the software, did all the integration. So a lot of the features which I personally see a lot of other organizations using netbox for, tracking which server is in which rack, with which ports and which VLANs, we just implemented all ourselves because we have the in-house know-how to do that. But another part of this is that we don't believe in fixed switch port assignments. We'd like switch configuration to be as uniform as possible, so you can just plug a server into the switch on any free port, and it'll just work. This is also very remote hands friendly. Our main data center is just up the road in Oberhausen, but our main office is in Halle-Saale, all the way in Sachsen-Anhalt. So we're not in the DC very often. And having this nice, simple switch config makes it really easy for the remote house to work on this on our behalf. So that's that for switch ports. And then there's the debugging in the lab. So when we were R&Ding this in the lab, the packets weren't flowing where they were meant to be flowing, and we had to work out what exactly was going on with all of this VXLAN nonsense. And at the time, we were trying to get TCP dump to do this for us, because we're a bunch of Unix nerds, so when we want to trace packets, the first thing we type is sudo TCP dump. And so you can type sudo TCP dump with the port number for VXLAN, I hope I got that right, and then grep for a MAC address. And this works, but it's a little bit cumbersome. You can't filter what's inside the VXLAN packets. And once you start pushing traffic over this from multiple sources, that gets a little bit cumbersome. And sure, Wireshark can do this, but on the CLI, that's really fiddly. And I happened to be reading through the TCP dump manual page, or rather the libpcap manual page, and I found that a function for examining the contents of encapsulated packets already exists for Geneve. I'm not sure I've ever heard of anyone actually using Geneve, but the functionality is all there and already half implemented. So in a fit of frustration, I spent 3 hours one afternoon implementing this. So you can now say TCP dump with your interface, VXLAN and then everything after the and is matched on the encapsulated packet. And I tossed it upstream, and it got merged. So everyone else can enjoy this as well now. We like open source. I do have another PR against TCP dump, which has been sitting open for a year and no one's merged it yet. So if anyone knows about TCP dump development and can put me in contact with the right people, that would be great. So after we debugged it, we had to get it all working, and part of that in our network is the routers. So we run an active standby router pair in every location. We don't have any full active for some historical reasons, which might be called stateful NAT. But we use Bird for BGP announcements to upstreams, and this is something we brought from the old network. And part of the failover automation, so if one router becomes unhealthy or it just needs to do a reboot for a kernel update, this then fails over automatically, attributes on the routes are updated, and then that all works fine. But we need to use FRR for the EVPN-VXLAN features. And so I spent a long time spinning on this. Do we keep Bird on the routers? Do we implement all this integration for FRR? And then a colleague came along and said, why not both? Why don't we just use both? And yeah, we run Bird and FRR. This is output I grabbed from a router yesterday. And with the benefit of hindsight, this actually worked really well for us, because now we have separation of concerns. So Bird is primarily responsible for everything to the outside world, and FRR is responsible for everything to our inside world. And that's actually really nice to have sometimes. And as a quick aside, we actually have a second Bird instance on the routers, because there's some other functions which came along which I never got around to integrating into the existing configuration. So I worked out how to get 2 Bird instances running on the same machine, and turns out this works as well, and that's pretty cool. So speaking of routing daemons, we need to talk about FRR, unfortunately. FRR is currently the only usable implementation of EVPN-VXLAN on Linux. Now, we're software people, and we are aware in the broad abstract that software has bugs. FRR is no exception here. FRR does have some bugs because it's software. Unfortunately, when it's network software sitting at the very basis of everything we build upon, those bugs can have a very big blast radius. Some are definitely worse than others. So the quick version of EVPN, for folks who maybe don't know too much about it, is it's essentially BGP for MAC addresses. There's this thing called a type 2 route, which says this MAC address is reachable over here. And this is how you then build up a shared layer 2 network by originating and announcing all these routes to everyone in a big full mesh, or through switches, or whatever topology you want. Optionally, you can also put IP addresses in these routes, which then gives you a MAC IP mapping. So like the neighbor table on Linux, ARP and NDP. And FRR will generate and consume these routes. So if it gets a MAC IP, or if it gets a type 2 route rather, with a MAC IP mapping in it, it will then manage this in the kernel neighbor table. There's a slight problem that, well, we have these active standby router pair, and there's a floating gateway address involved. And we run into this extremely frustrating problem that sometimes when a failover happens, the root seeing the mapping of the router, of the floating gateway address to this router MAC address gets stuck. And this then means that every server in our data center has an incorrect mapping for the floating gateway address to the corresponding MAC address. And for routing, this doesn't really affect things because the routers all have forwarding turned on anyway. This blows up with DNS because these DNS requests are then sent to an IP address which is not locally assigned on the machine, and the resolver is not listening there. Now, as far as we can tell, this is somewhere in the kernel netlink handling, and this is some crazy race condition which I don't know the FRR internals well enough to debug. The proximate cause, though, is that it's something to do with neighbor table management, somewhere in there, that general direction. So I came up with a very stupid solution, and that's if I comment out these 2 lines of code, then FRR stops managing the neighbor table. All of our Linux machines fall back to doing dynamic ARP and NDP discovery over the VXLAN fabric. This just works, thankfully. So we've been using FRR for a year and a half now, and it certainly works, but really we feel more at home with Bird. And it'd be nice if we could use Bird for this, but Bird doesn't really have EVPN-VXLAN yet. So we've been on the phone to CZNIC, who are responsible for maintaining Bird, and they've been open to collaboration, so we're going to collaborate with CZNIC to help finalize and test the VXLAN functionality, the EVPN-VXLAN functionality in there. So watch this space. We're very excited about it, and given the complexity of EVPN, we're also interested in having a commercially supported alternative to FRR as well. So some closing thoughts on all of this. Can software people use EVPN? Yes, of course. Well, we did it. Our network is now significantly more complex. And one of the big changes which came with EVPN was actually an organizational change. We've had to change how some of the responsibility for our infrastructure is distributed. And now that we have more software in the picture, there's more moving parts and more sources of outages. There are more ways things can explode. But on the other hand, software-defined networking is still just software, right? And we're software people, so we're playing on our home ground. We know application operations. It just so happens that we now have another application in our network. So we're able to lean on a lot of the knowledge and experience that we have with that for operating our network as well. And this includes things like automated testing and QA, which is something that we think is good because we do software, and we think that the rest of the networking industry could do that as well, and that would be cool. So, yeah, that's everything I've got.
Thank you, Molly. Are there any questions? Please show your hand, and I will come over with the microphone.
All right, I'm Robin. A great presentation, thank you. So my question is, you said you're running Bird and FRR in parallel. How are you interfacing those? Like, are you running separate BGP sessions, or how does that work?
So they're running separate BGP sessions. So BGP talking to our upstream provider to announce our prefixes all runs through Bird. And FRR is what talks to our switches. And we have these bound to separate interfaces. So the interfaces have different functions, and the routing daemons are bound to those interfaces to ensure that the routing, the BGP sessions stay on those interfaces.
All right, thanks.
More questions? Oh, at the back.
Hi, Q. So you talked a lot about how
things went wrong on the Linux side of things. But did anything weird happen with the switches, or did the switches mostly just work when you plugged them in?
We definitely had to spend more brain power on the Linux side of things. With the switches that we have, which we're using for this, those have more or less just worked. It hasn't been that we found any game-breaking bugs in EVPN implementations on switches, which we've then had to get a vendor to fix. It's mostly been software has bugs, which goes for the switches as well, but most of the effort that we had to put into that was on the Linux side.
So you would say that the vendor side on switches of EVPN is fairly mature and...
It's a lot more polished. It's definitely a lot more polished.
Okay. Any more questions? Any online questions? No online questions. Any more questions in the room? Oh, yeah. This is getting exhausting.
Tom, I think you just made people very, very happy with saying there's EVPN coming in Bird. But can you share a little bit about the timeline or how people can test?
As far as I know, this is a work in progress which is nearing completion. And we spoke to them being CZNIC in the past couple of weeks. And we happen to have a lab set up for doing routing work, which we're hoping to give them access to, and then things might happen sometime next year. It's all still a little bit up in the air, so I don't have anything more concrete than that at the moment.
Thank you.
All right. Any more questions? Thank you, Molly.